Controlled Environment Plant Production Engineering and Technology Education Modules. My name is Gene Giacomelli. I'm from the University of Arizona, and with my colleague, Dr. A.J. Both from Rutgers University, we put together this educational module of new opportunities and future outlook of controlled environment agriculture. The content will include describing what controlled environment agriculture is and how the industry has technically developed, what it's accomplished, and where might it be in the future. Examples of specific application of controlled environments will be provided, and information that you can go back and look up some of the references that we've used in this discussion. The primary objectives. We want you to be able to define the term CEA, plus recognize and appreciate the multidisciplinary character of the CEA industry, which includes engineering science, plant science, and the development of the horticultural science for food production. Also to have an understanding about the past technical accomplishments and the future directions of the CEA industry. And finally, to understand the importance of the CEA industry in the increasing demand for fresh, healthy foods that are grown in a way that minimizes environmental impact. CEA can be defined as an integrated science and engineering-based approach to provide specific, controlled, and repeatable environments for the production of plants or plant products, while optimizing resources, including production materials, water, energy, space, labor, and capital investment. You might say that CEA systems can produce any plant anywhere at any time. And this is because many forms of greenhouse, growth room, plant factory, and most recently vertical farms have been developed to provide the controlled environment to produce these crops. 3 components are required for overall success. Engineering, science, and horticultural knowledge is necessary for the technical success. Experienced and educated labor is necessary for the production success. And finally, good marketing and sales is necessary for the economic success of any viable controlled environment plant production system. Where has the industry evolved and where might it be going? The innovations from the 20th century were focused on resource conservation, while innovations in the early part of the 21st century have been and will continue to focus, yes, on resource conservation, but also on resource reutilization and resource generation. Innovations from the 20th century can be described as resource conservation procedures, multi-layer glazings with rigid plastics and double air-inflated polyethylene film to save energy, heating energy, particularly in the night. Filtered glazings to reduce radiation heat loss, the thermal long-wave radiation in the night. Energy screens that are movable, that also add insulation only in the nighttime and are stowed appropriately not to shade the plants during the day. Improved microenvironment control. One example is root zone heating, providing the heat to the location adjacent to the plant and its microenvironment. Drip irrigation and hydroponics, watering and fertilizing efficiently and precisely to provide what the plants need to grow. Automation is in general, climate control automation, irrigation automation, and materials handling. All of these were developed to save labor, to save and utilize water and nutrients more efficiently, and to save energy in the climate control. And finally, information. Computerization allowed the collection, the storage, and the analysis of data, which began to give the grower, the user, the operator of the system a better understanding of how it worked and how it might be improved. Essentially, the strategy was to invest in hardware and control systems to improve overall resource use efficiency. These can be summarized from the North America research and application experiences in a publication called Greenhouse Engineering by Bob Aldridge and John Bartok. It's number NRAIS 33, and there's a link here where you can find it on the internet. Innovations for the 21st century will focus on resource utilization and resource generation. Recirculating hydroponics, that is water and nutrient recycling of close to 100% of water and nutrients and no discharge into the environment. Organic hydroponics, where inorganic nutrition is replaced by organic nutrition provided from plant biomass or animal sources. Integrated resource systems, utilizing cogeneration, where one fuel is consumed to provide two resources. Example, engine generator system, which provides electric power and heat for heating the greenhouse. Ground source heat pumps and biofuels as alternative resources for keeping greenhouses warm, and solar energy for generating electric power. Recirculating atmosphere, the semi-closed greenhouse, where systems are developed to recycle the air in the greenhouse and not discharge it immediately, but that maintain a high CO2 concentration for improved plant growth while reducing water vapor from plant transpiration to remove it from the air and then to potentially reuse that water. Finally, non-greenhouse controlled environment systems, those that do not use the sun to power the growth of the plants, but are indoor, such as growth rooms and vertical farms inside the buildings that require electric power. These will be developed to a better efficiency in the 21st century. Finally, we'll recognize that in the 21st century, we'll continue to do resource conservation, developing alternative energy sources from non-fossil fuels, whatever they may be. Mechanization, where we can, for example, move plants more efficiently, particularly when they need respacing, but essentially reduce labor costs. Automation, robotics, again, labor for harvest has always been available, becomes more difficult in the future, and robots may begin taking over that task. Zero carbon footprint, minimizing the amount of carbon that is put out by the system and recycling into the system for a net zero carbon footprint. Greenhouses and innovative technologies can range from low-tech to high-tech, all being ultimately with a good design and appropriate technology. Low-tech engineering systems include high tunnels, which we'll see shortly, a basic technology at low cost for producing plants in a controlled or semi-controlled environment. The open roof greenhouse, which improves the natural lighting available for plants by physically removing the roof at times of the day when it's appropriate and closing it up when necessary in the evenings. The high-tech engineering systems that are computer monitored or controlled, that are integrated power generation systems, such as photovoltaics and other solar collecting devices. The semi-closed greenhouse, we'll see photos of it, such as those designed by the Kubo company and the Gates design. It's all advanced technology for improving productivity and resource utilization. Urban farming, growing on rooftops with greenhouses or plant factory and vertical farms inside of buildings. Bioregenerative life support systems that will provide lunar and Mars greenhouse that offers not only food now for the astronauts and space travelers, but also their oxygen and their fresh water. Telepresence in agriculture will be the transfer of information from remote monitored and controlled systems, having the possibility of the operator not even being adjacent to the production system. Biologically focused systems, such as using biofuel development with algae as a photobioreactor, using artificial lighting, or open raceway systems using natural sunlight. Transplant production through micropropagation and grafted seedlings are necessary for improving productivity of the plants in the greenhouse production. Bioremediation of soil, water, and atmosphere, using plants with their natural processes to filter components, unwanted components from the soil, from the water, from the atmosphere. Bioremediation. These are new innovative systems. Finally, plant phytochemicals, the phytopharmaceuticals for developing plant-based vaccines. Examples for the Ebola virus and hepatitis C virus vaccine. Nutraceuticals, high lycopene tomato and the Rutgers scarlet lettuce for improving the nutritional quality of these products using controlled environments and specialized varieties of these different vegetables. Improving the quality of life and enhancing that through indoor plantscapes and the use of horticultural therapy. All innovative controlled environment systems. General types of controlled environments, the most common was and is the greenhouse. It's indoor, has a transparent cover, uses solar energy for lighting and heating the greenhouse. It is commercially viable everywhere throughout North America and the world. It has different levels of technology. On the left, you see a high technology greenhouse, high productivity, high cost. On the right, you see a low cost, high tunnel greenhouse technology at low cost and lesser productivity on a 12-month basis. Here's the close-up. You see there is no hydroponic system here. The plants are growing directly in the earth, in the soil, in the base of the structure, which is a simple metal frame structure with a single layer of polyethylene film with roll-up sidewalls, no fans, no electric power for ventilation, just natural ventilation, and many times no heating for warming in the nighttime either. Thus, it's a much more seasonal growing system in contrast to a high technology greenhouse. An aerial view here of a 40-acre block of glass greenhouse, having all the technologies, computer control, monitoring of the plant in real time, providing for decision support to help the grower make better decisions about how to change and modify that environment to improve energy conservation while you're improving plant productivity, using alternate energy sources, cogeneration, monitoring and controlling labor to reduce costs and improve management, developing markets because there is a need for a lot of product to move through this system on a daily basis. Ultimately, to optimize the plant environment for its productivity and to reduce its operational costs. Looking inside, here's the image of the high technology greenhouse growing tomatoes. 12 months continuous production of tomatoes, harvest multiple times every week throughout the year. High technology, glass structure, well developed, hydroponic for root zone control, and climate control for the aerial part of the plant. This also might be a small statured crop like lettuce. This is hydroponic lettuce that's floating on boards in ponds on the floor of the greenhouse. Above it is the high technology controlled environment greenhouse. The semi-closed greenhouse, almost a step above the high technology greenhouse, because it does close the system whenever possible, meaning you do not ventilate the inside air, you recirculate it. You see on the right the tomato plants being grown above these plastic tubes. The cooled, dehumidified, and CO2 enriched air is driven and forced through these tubes and comes up at the base of each plant, providing the carbon dioxide, the proper temperature and humidity levels to increase the productivity of these plants. Hydroponics, yes. Energy derived from photovoltaics, yes, part of these systems. The ability to recapture all the water that is put into the hydroponic system and lost through transpiration of the plant, put into the air, can be recondensed. In addition, heat storage, using cogeneration systems to generate the CO2, but also generating heat and storing that for the nighttime. Aquaponics is a plant growing technique that combines aquaculture and hydroponic plant production. It can all then be put into a controlled environment to optimize, under sunlight conditions, the growth of the plants in the floating hydroponics, and the first opportunity to use organics. The waste product from the fish is processed and then provided to the nutrient water to the roots. You see them hanging in the air here on the floating styrofoam board. Underneath is the roots that are in the water that are being provided the nutrients from the waste product of the fish, and dissolved oxygen is added to the water. And the water then is recirculated back to the fish system, and essentially 100% of the water is utilized in this system. Rooftop greenhouses are really an application for urban agriculture. Here we see in New York City a greenhouse of 12,000 square feet on the rooftop of a building, providing fresh greens and herbs at relatively good prices for the grower on a daily basis, harvested in the morning, eaten and consumed by evening. Fresh, nutritious vegetables in controlled environments. The next type of controlled environment is the plant factory. Now we're inside a building using artificial lighting and still using hydroponic recirculating nutrient systems for the root zone of the plant. It's a very efficient use of space, land in particular. In the urban areas, it makes a lot of sense. Also, water use can be 100% efficient in its recycled system. Fresh, pesticide-free produce is provided. You see the multiple layers that require indoor lighting with artificial lamps, providing the energy, which adds to the expense of operation. The technology in its exact form is still in development, and that will remain to be seen. But at the moment, there's an insufficient amount of human experience and expert resources to operate these systems. But they are developing as we are discussing this quite extensively. Close-up example of a lettuce production system in Japan, and you see the extent that you go to for the cleanliness and the high quality of development of those plants. A food growth room, another type of growing system that is a part of in this case, it's the South Pole Station in Antarctica, but it could also be adjacent to a restaurant or to a hospital, where it's enclosed using artificial lighting and, again, recirculating hydroponics, providing fresh vegetables, in this case, bright and humid environment, which the people at the South Pole need desperately in their dark, long winters of 6 months, having fragrances that make the area smell good, and the opportunity to be in contact with plants as a gardener increases the psychological capacity and health of the people living and working in those extreme environments. Here's an example of the sitting room that was developed to be in front of the food growth chamber at the South Pole. They used it for many things, for just relaxing, but even in this case, celebrating a wedding anniversary in the improved temperature, higher humidity, and good opportunity to have a glass of wine with some fresh veggies. What new technologies are required to further develop and expand controlled environment systems? Climate controllers, inexpensive and robust climate controllers that use wireless sensors and can collect data and live video to support telepresence, that is, the remote control and monitoring of these systems. We'd like to have self-calibrating and multiple communicating sensors that can give us more data, not only about the aerial environment around the plant, but the environment and the status of the plant itself. Improve plant photosynthesis. Make it more efficient, fundamentally, with ultimately providing more growth under lower light conditions, therefore lower cost. Solar photovoltaic power. Put that into the system of a greenhouse without reducing the light that's needed for plant growth. Many of these systems are installed on rooftop of the greenhouse and shade the plants below. A tunable glazing. That is, we want the light to have a different quality coming through, the number of colors of the light, to change that light quality, and ultimately the transmission. We might want to reduce the amount certain times of the day to shade it, and other times of the day have it maximum, and ultimately change the glazing to improve and enhance its energy conservation at night. Developing energy generation and conversion systems for heating, cooling, and humidity control, an ongoing effort that should never stop in its development. Smart or even smarter robots, particularly those for plant maintenance to reduce the drudgery of some of the work, but also to improve the quality of the work in the harvesting operations that can get heavy and require transportation of the harvest. Life cycle assessments, ultimately to be used for the evaluation of the environmental impact of these systems, to determine what the environmental costs and energy costs are for developing, building, installing the system, and then for its essential recycling at the end. What else do we need to consider? Why not have breeding that develops new plant cultivars that are specifically optimized for production in controlled environment systems? We need to recognize the importance of marketing, to emphasize that to our students and to those getting into the business, that we can help you in the design and operation of these systems to grow the product. It still remains a challenge to be able to market and sell that product. To value education and the experience that goes with operating these systems. An important aspect that everyone needs to develop respect for these new 21st century agriculturalists. Realize that growing plants is not just a skill, a technical skill that's developed. It also still remains very much an art, in part because we're looking for a variation of products, different aspects, different utilizations, and we're looking for certain quality at the same time. an art, and a science. Finally, to understand some basic physical principles, we must follow the laws of physics and biology. We cannot break them in the design and the attempted operation of any of our systems. And ultimately, to understand a bit about energy transfer efficiency, that is, heat and mass transfer, the efficiency of converting one form of energy into another so that we can have a process occur. Classic example is photosynthesis, collecting solar energy and converting that into production of biomass, green matter, and harvestable product. Finally, there are 2 slides which give you some web references, particularly to some of those that were mentioned, the businesses that were specifically mentioned in the discussion. I want to thank you very much for this opportunity to speak to you. I wish you the best in your interest in controlled environment agriculture today and into the future.